we saw that once we have created a heap, a new person coming in, a new patient coming in is not a problem, because in an order of log of n operations, where n is the number of items in the list, we can again restore the heap structure through a process of percolating upwards, because basically we add the item in the end and then just have it percolating upwards. In log of n operations, the at most it will reach the right position. Now what happens if the person on the top is sent for service? Clearly it's no longer a part of the waiting room. So this person must be now removed from the list here, because now we must look for the minimum, let's say the minimum or the highest priority patient or the minimum priority score patient in the remaining items. We'll see how this happens and how the heap structure gets restored again very, very efficiently. In fact, the process we follow, we just say that take the last item of the heap and move it to the top, and then let the ball roll basically. So essentially we are saying that, okay, look, this is my original heap. Notice I've included 6 in this because this patient has come in. So at some point doctor says, okay, please send the next person for, let's say, treatment. So you say, okay, this person with priority 3, please go, which means that this list no longer has 3. So what I will do is that I'll just take the last item, which was 13. Notice this is 13, and move it all the way to the top. Now clearly this will cause a violation of the heap structure, because notice this is no longer a heap. This node 0 is 13, its children are 5 and 6, clearly not a min heap. However, I just need to do a little bit of work to get it back to be a heap again. And what is that work? Well, to start with, I will swap 5 and 13. So basically I'll find the smaller of the two children, and I will swap this with the with the root. So that will cause basically this, right? So I have fixed it as root. However, I have caused this violation to appear somewhere else. Notice 13 is now more than 10, and that's a problem. So I need to fix this again. One more interchange, and again I am back to my heap structure. So really, really, really amazing. Think about it. Once again, we can argue that at most log of n steps, I will have my item percolating down to the right place. See the difference? When I was adding the item to the heap, I added it to the end, and that item percolated upwards. In this case was 6. When I'm removing an item, I'm taking the last item, putting it on the top, and it is percolating downwards. However, the number of steps cannot exceed log of n, because all I do is to go on a certain path. Every comparison brings me down one level, and this is the total number of levels. Very, very, very beautiful, really amazing. This whole thing feels so nice that I kind of create a perturbation in this. I create disturb the structure, but the structure has the ability to restore itself. Obviously, just like earlier, we can write this code ourselves. In fact, I've given a example in the appendix. Likewise, we can also write the code for customer coming in ourselves. I kind of missed mentioning that in the video, but we have the code available. But just like we did previously, we can also use the heap queue module. There's a function called heap pop. Remember, heap push was adding this item to the heap. Heap pop is basically saying that, okay, let me pop out the first guy, the top item from the list, which happens to be the lowest priority. So see this carefully. I had this list to start with. I heapified, which means 3 went on top. I pushed 6 into it, so that was a new heap created. I popped, which means 3 is going to get removed, and now the top priority is indeed 5. And that's exactly what I saw here. Once again, my highest priority item has moved up to the top, which is exactly what I wanted. Remember, my goal was to give treatment to the highest priority customer without losing anybody else. So if, let's say, new customers stop coming, once again I pop this out, I'll move 25 to the top. 25 will percolate to its right position. In fact, 6 will end up on the top. So you can keep doing this multiple times. You can use heap pop. You'll realize that always you will have the highest priority customer available to you, at the top of the list. And that's exactly what heap is buying for us. Heap pop does that quite well. Yeah. I hope you found this interesting. Do think about it. Do try to visualize how this entire process is coming through. I think it's very, very interesting. Look at our website www.ybyte.in for more such material. We learn programming in a fun way, but we are extremely rigorous about our explanations, and we always enjoy coding. Take care. Thank you so much. Bye bye.